Today we're going to look at factoring polynomials with four terms, and we're going to do that using a process called factor by grouping. So our problems today will look something like this. We'll have 1, 2, 3, 4 terms, and we're going to try to factor them into two binomials. A quick refresher really fast that we need to know before we start this is when we're factoring anything, we always look for a greatest common factor, a GCF. So for example, this binomial right here, 5xy plus 10xz, if we were looking for the GCF, the greatest common factor, it'd be 5x. So we would take the 5x out, and then we'd be left with y plus 2z. So this right here is fully factored. So we're going to use that concept of a greatest common factor to help us factor something a little bit more complicated like this right here. Okay, so a couple examples just to get us warmed up. We have 3ax minus 7bx. Again, we always look for a greatest common factor. The only thing these have in common is an x. So we can take that x out. We're going to factor it to the outside. And if we divide each piece by an x, we're going to be left with 3a minus 7b inside. Okay, if you look at our next example, it looks a lot more complicated, but it's actually very similar to example 270. We still have the 3a here, we still have the minus 7b here, but notice we have this 2a plus 5b on this first group, 2a plus 5b on this second group. So I tried to color code them here so we could kind of see the similarities. Just like we took an x out here, because both pieces had it, both pieces have a 2a plus 5b in this example, so we can take that binomial out. That's what we are talking about up here. When we are factoring a greatest common factor, it could be a binomial. So they both have that purple piece, that 2a plus 5b. If we divide these by 2a plus 5b, well, those cancel out, and we're left with this thing and this thing. We're left with 3a minus 7b. So now these two binomials are two factors. This is fully factored. So we're going to use that idea of factoring out a binomial to help us factor things that have four terms, to help us factor four-term polynomials. And we're going to do this with a process called factor by grouping. And the reason we call it factor by grouping is I'm going to group up my first two pieces. I'm going to group up my last two pieces, and the first thing I'm going to do is look for a greatest common factor for each of my groups. So if we look at just our first two pieces here, 10ab plus 15b, well, their greatest common factor, their number is 5, and then they both have a b. So if we take a 5b out, it's like we're dividing each piece by a 5b. We're going to end up with just 2a. If I divide this one by 5b, I'm going to end up with plus 3. Now let's do the same thing with our green part right here. We have a 4a plus 6. Well, they don't both have an a, so we can't take out a letter, but they both can be divided by 2. Their greatest common factor is just a positive 2. So I'm going to put a plus here since it's positive. If we divide each piece by a 2, we end up with 2a plus 3. Well, look what happened. Now this looks like the example we did above. Now we do have a binomial greatest common factor. They both have a 2a plus 3. So I'm going to take out that 2a plus 3. If I take that out, if I factor that out of both of these, I'm left with 5b plus 2. So we end up with 2a plus 3 times 5b plus 2. And we could always check this. If we wanted to check and make sure we were right, we could just multiply these binomials back out, make sure we end up with what we started with, and then we know that we're correct. Okay, a few more examples like this. On this one right here, let's group it up. I'm going to color code it like I did on the last one. We have our first two. We have our second two. We're going to look for a greatest common factor for this pink group here. Well, we can divide them both by 3. We can take out a 3. And they both have at least one x. We can't take out a y because that first one doesn't have a y. So if we divide each piece by 3x, And you can write that step, that division or not, it's up to you. I end up with 2x plus 3y. Let's do the same thing with our green one. We have negative 14x, negative 21y. I can divide both of those by a negative 7. And notice because this sign was negative, I'm going to take that negative out with it. So it's like we're dividing each piece by a negative 7. And we end up with 2x plus 3y. And you'll kind of notice the pattern here. If we do factor by grouping correctly, we should end up with the same binomial right here, because now we're going to factor that binomial out. We're going to take a 2x plus 3y out of both of them. If we take that out of both of them, we're left with a 3x minus 7. And those are our two binomial factors. These are fully factored. Okay, same process here. Group up your first two, group up your second two, and let's see what we have in common. Let's look for a greatest common factor for our first one. We can't take out any numbers. 5 and 8, their greatest common factor is only 1, so we just take out a variable. They both have an x that we can take out. If I divide both of them by x, I'm left with 5y minus 8. And then here, negative 10y plus 16, I can take out a negative 2. If I divide them both by negative 2, I end up with 5y minus 8. Again, we know we've done this correctly if this binomial matches this binomial. Now we can factor out that matching binomial. If I take that out, I'm left with x minus 2. And there's my two binomial factors. All right, and then one more like this on this page. Group up my first two. Group up my last two. Let's see what we have in common on the first two. We definitely can take a 2 out, and they also both have an a. So I'm going to take a 2a out of the first one, 2a out of the second one. If I do that, I'm left with 6b minus 7. Okay, right here, they don't have any common factor other than 1. And since this term is negative, I'm going to take out a negative 1. If I divide both pieces by negative 1, all that changes is I flip my signs. 6b minus 7. Now we know we've done this correctly because this matches this. I'm going to factor out that matching binomial, 6b minus 7. If I do that, I'm left with 2a minus 1. Those are my two binomial factors. All right, a few more here just to see the process a couple more times. I have 4 terms, so I'm going to group them up. If I look at my first group here, I can take out a 3. And then look at our variables here. They both have at least an x squared, so I'm going to take out an x squared. If I divide each piece by 3x squared, I'm left with 2x minus 5. And then notice for this one, they have nothing in common. The only greatest common factor they have is a 1, so I'm going to take out a positive 1, and I'm left with 2x minus 5. We've got our matching binomials. We're going to factor that out. That becomes our first binomial, 2x minus 5. When we factor that out, we're left with 3x squared plus 1. Okay, so let's look at this next one. Let's see kind of what the problem is here. I'm going to group these up. And then notice if we look at our first group, these two do not have a common factor. They only have a 1. So let's just see what happens. You don't have to write this down. I'm going to erase it in just a second. But if I take out a 1, I'm left with 4a squared minus 21b cubed. Nothing changed there. The second one, I could take out a 2ab. If I do that, I'm left with 3 minus 7b. Well, obviously, I do not have common factors here, so that factoring by grouping like that really didn't help me. So if we try it like this, and we do not end up with those matching binomials right here, one thing we can try is to rearrange this problem. So I'm going to put a little star here and put rearrange. We're going to rearrange it to see if we can take out greatest common factors that might be a little bit more useful. So let's see, I'm going to put my 4a squared and my 6ab together like this. And then I'm going to put these two together. Minus 14ab, oops, minus 21b cubed. And the more you do these, the easier it will be for you to see what needs to be paired together. Generally, if you see right here, we like, whoops, I forgot a squared right here. Generally, we like to see like our a squareds be at the front. Our highest power of a's at the front and our highest power of b's at the end. That's generally how we set these up. So let's try it now. Let's group up our first two. Group up our last two. If we look at our first two, we can take out a 2a, and I'm left with 2a plus 3b. Here, I can take out a minus 7b squared. If I do that, I'm left with 2a plus 3b. So rearranging that helped us because now we have that matching binomial that we can factor out. We take out a 2a plus 3b. When we do that, we're left with 2a minus 7b squared. Okay, let's try example 279 and see if we need to rearrange or not. I'm going to group up first two, group up last two. The first one, my greatest common factor is 1, so if I take out a 1, nothing changes, 7 plus y. My second one, I can take out a negative 3x. If I take out a negative 3x, let's see, I'm left with a y plus 7. I know that these don't necessarily look the same, but 7 plus y and y plus 7 are equivalent. So you can write it either way. I'm going to write that as y plus 7. If we do that, we're left with 1 minus 3x. All right, and then our last one here. I'm going to group up my first two, group up my last two. Let's see what we can take out on the first one. We can take out a 4x, and I'm left with 2y minus 3. Next one, I'm going to take out a positive 5, and I'm left with, let's see, 3. Whoops, what did I do here? Oh, hang on. Back up, back up. Let's fix this. I can't take out a 4x because this one doesn't have an x, but I can take out a 4y. If I do that, I'm left with 2y minus 3. That looks better. Okay. And then here, so now I need to fix. Sorry, stick with me here. Got a 2x. Is that right? 2x minus 3. There we go. All right, so for this next one, we take out a positive 5. If we take out a positive 5, we're left with 3 minus 2x. Okay, so notice here, I know this doesn't look like these two things are equivalent. So if we look at this, I'm just going to rearrange this order. This is really the same thing as negative 2x plus 3. Okay, so look, this and this are almost equivalent, but not quite. My signs on this second one do not match the signs on the first one. So one thing that we could do is just change this to a negative 5. It's going to change both of these signs. So let me rewrite that one more time. 2x minus 3. I'm not going to change the first one because that's fine. I'm going to change this to taking out a negative 5, which is now going to flip this to a positive, flip this to a negative. It's going to turn into positive 2x minus 3. Now these are the same. Okay, so now we can take out our matching binomial, 2x minus 3. We're left with 4y minus 5. Okay, so this process, just a reminder, is called factor by grouping. We call it that because we group up our first, we group up our second two, and we look for greatest common factors. We will use this process in the future to factor other types of polynomials, specifically quadratic trinomials.